The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
Good afternoon, everyone. My name is Dr. Charlene Ortiz, and today we are going to continue with our lecture in regards to surveys and correlations. Now, previously, we covered the first section of this lecture, and in this regard, we covered aspects of surveys. What are surveys? When do we use surveys? What does it take to construct a good survey? What should items look like whenever you are conducting your survey and trying to develop your own survey or assessment tool? We also talked about ethical considerations that may come about whenever you are administering a survey. So today we're going to continue with this lecture, but now we're going to talk about the correlational side of things. All right, so let's get started. In regards to a correlation, some of you may be very familiar with a correlation. I also have a previous lecture that covers in-depth correlations, and I will be linking it down in the description below. So in regards to correlations, let's talk about the correlational design. One of the first things that we need to understand is that generally, when we are looking at a correlation, right, we're generally referring to two or more factors, right? What we're trying to ascertain in that process, we're trying to estimate if these factors are related, right? Or if they change, right? In an identifiable manner. Now, why are we talking about correlations when we're talking about surveys? Well, generally, surveys often use correlational research design, right? So that's one of the reasons why we are including correlations in the sense of surveys, right? So that's the relationship. Generally, when we are determining our data in our surveys, we tend to look at it in a correlational fashion. Now, if we go back to our slides, notice that in a correlational coefficient, right? So how is it that we know how strong this relationship is, right? I'm trying to find out how, first of all, if there is any relationship. And our second step would be, let me find how strong that relationship is. Well, that's what my correlational coefficient is, right? That's what my correlational coefficient is. I'm trying to find out, first of all, the strength, right? The strength of that relationship. Secondly, I'm trying to find out the direction, right? The direction of that relationship. Now, I do need you to keep in mind that whenever we are referring to this statistic presently, we're only talking about a linear relationship, right? What do I mean by a linear relationship? We are talking about a linear relationship. Think about how one factor, right? Think about how one factor is going to influence the next factor, right? Think about how that factor is going to influence the other. But generally, if we go back to our slides, that relationship looks as such, right? So it looks basically in a straight line, whether it be a positive relationship or a negative relationship, right? Now, there are other types of relationships, right? We have, for instance, whenever we have an exponential relationship, so we may have an exponential relationship, but for the time being, I only need you to focus on the very first two that I mentioned, positive or negative, in regards to a linear relationship. Again, relational coefficient tells me about the strength and direction of a linear relationship, right? Should there be, in fact, a relationship between them. Now, we have talked about before, right? We have talked about before correlation coefficient. Something I want you to remember, if we go back to our slides, this correlational coefficient, right? This correlational coefficient, it's generally, right? Generally referred to in the value of R, right? So generally, we refer to a correlational coefficient with the letter R, okay? Generally the value that we are going to evaluate. Now, remember, right? Remember, I'm going to clear this slide up for everybody. So notice that the value of R, right? R, and remember, R refers to that correlation coefficient, right? The strength and direction. R can go anywhere between -1, right? 0, and then it can go all the way up to +1. Why is this important? Right? So when I have a correlation, right? If the value is 0, that is telling me there is no correlation, right? If the value of R is 0, it is telling me that there is no correlation. But if we move on back to our slides, you'll notice that I wrote down -1, and it can range all the way up to +1. Well, that is because -1 and +1 respectively refer to perfect correlations, right? Ideally, that's what we would like to see, a perfect correlation, whether a -1 or a +1. Any questions so far about a correlational coefficient, right? Any questions so far, people here and people watching live online? Good deal, good deal, fantastic. Now, when I say a perfect correlation, right? What I'm talking about is the closer a value, right? The closer a value is to +1 or -1, the stronger that relationship is. It almost translates into real relationships, right? The more perfect the relationship, the stronger you have a relationship, like friends and stuff like that. So that's a good way to remember it, right? So if I say we did a correlation and we found out, hypothetically, that the amount of times you don't show up to class is related to your grade, right? There's a relationship, and say we found a 0.96, right? So really close to that -1. That is telling me that there is a strong relationship, almost perfect relationship, between the amount of times you don't show up to class and your grade. Now, in keeping with the same example, right? The more you don't show up to class, the lower your grade. Notice that the number gave me the strength. The symbol, whether it's negative or positive, gives me the direction, okay? So number gives me the strength, and symbol gives me the direction, okay? Sometimes we get that confused, and I'll say it again. The number gives me the strength, and the symbol gives me the direction. Any questions so far about the range of that coefficient? Right? Any questions online? Right. Good deal. Now, if we go back to our slides, I want you to notice that any direction that we have can either be positive or negative, right? As I mentioned earlier, the relationships can be positive or negative for my linear relationship for the moment, okay? Ideally, we're trying to find out how close are we to that negative and that positive, right? We're trying to find out how close are we. So if I were to draw, right? If I were to draw a relationship, So let's look at a relationship here. Say, for example, this is the same relationship we're talking about, right? The more absent you are to a course, so for example, you had 10 times you didn't show up, 5 times you didn't show up, 0, right? You were always in class. Or here are your grades. For example, getting a 0 in class, getting 100 in class. The more absences you have, right, the least grades you're going to get. So for example, 10, right, 20, et cetera, et cetera. Now, when data falls in this line, right, and you're thinking, well, this would be my perfect relationship. This line here is what we refer to a regression line. The regression line is basically that perfect relationship that we're basically shooting for, right? We want a strong relationship most of the time. So if I have data, generally what I like to refer to as behavior, right? So if I have, Peter's score, Jessica's scores, Yolanda's scores, and I have, let's say, Brian's score falls right on the dot. Notice that these data sets are generally behaving in this direction, right? They're generally behaving in that direction in a negative relationship. And they're basically generally falling onto this regression line. The stronger that regression is, right? The stronger I am to -1 or +1, the better predictability, right? I am able to predict those 2 factors, right? So in the case of that fictitious example that I gave you, let's say the strength, right, is 0.96. That tells me that those data points are very, very on top of that regression line. So without me even looking at any numbers, when I look at my scatter plot, I can tell you how strong that relationship is. So any questions so far for my people online or in person? Good deal. I mentioned a scatter plot. Well, what is a scatter plot, right? A scatter plot is a display. It's an illustration, right? It's an illustration of all these data sets, right? So here we have an X and a Y. I know for some of you, we've covered this before, but I'll mention it very briefly, which is, it's a really easy way to remember it. This is how I used to remember when I first started college, right? So X falls here, and then Y is my vertical, and I like to remember Y is the vertical because why would you jump up a bridge, right? Why would you jump up a cliff, right? That's silly. So therefore, this is my Y. That's a really good way to remember which one's which. With the scatter plot, I am able to provide a summary, right, of that relationship. I am able to provide a summary of this relationship. Any questions so far about the strength and relationship, the direction, or the scatter plot? Good so far? Good deal. Good deal. Well, referring back to our slides, notice that we're going to have these data points. I also refer to them as data sets, right? We can also refer to them as observations, right? So I do use these terms interchangeably. So I do want you to remember that I will use these terms interchangeably. And basically, what we're trying to do with the data points is that we're going to plot, right? We're going to put them in our little graph. So we have a value for X, value for Y, for each plot, right? So for instance, if we move on to our next slide, you'll notice, right, that here, right, we have our value for X, our X-axis, and we have our factor for Y. And notice if I wanted to plot a coordinate, for those of you who have played Battleship, right, so it's really similar to Battleship. I will have a coordinate, so for example, 1, 1. So for instance, in the example that I gave you, right, grade that you have versus the, well, not in this one specifically, but the more therapy you receive, the better you would feel, right? Say, for example, about self-esteem, that will be a positive relationship. So notice that this here is my XY, right? It's my little coordinate, right? That point in that data set, that observation. Any questions so far of what the X, Y factors are? Okay, that little coordinate, that data point. Now, in keeping, right, in keeping with our slides, notice, as I mentioned, that we have a regression line, right? And that is the line that best predicts, right? It's the best fitting straight line. And remember, just for linear relationships, right? So it's going to be straight. Going to be straight. It is that best fitting line that allows me to provide a prediction of where those data points are going to fall. Any questions about the regression line? Okay. Good deal. So if we go to our next slide, if I clear all the data, so we go back to our slides, you'll notice that here in this illustration, right? So I'm going to clear this up. Notice that here we have the illustration of a scatter plot, right? And as I mentioned, a scatter plot is that summary of all that data, right, that you collected. Now remember, when we have a positive correlation, means that when one value goes in one direction, the other value would go the same direction, right? It goes upward in the case, on this case illustration that you have here. So for instance, the more therapy sessions, right? So you have one therapy session. So I'm going to illustrate therapy as TX, by the way, that is the common T on the script X. So say, for instance, the more therapy sessions, so 1, 2, 3, etc., the better the score, say, for instance, for self-esteem, right? So we have a score of 1. If I have 2 sessions, that'll have a score of 2. So notice that when one data set, right, when one data point went up, the next data set went up. That means that these factors are going to change in the same direction, right? So if one factor increased, for example, the amount of therapy, notice that your self-esteem, for example, increased, right? And again, these are, of course, hypotheticals. Now, by the same token, I don't want you to think that positive means increase. Positive in this regard only means direction, right? So that also applies, say, if one factor goes down, the other factor will also go down, right? So the least, an example would be, the least a person is able to communicate their feelings, the worse they're going to be. Those are both negative. You're going downward, but that represents a positive relationship because they're both going in the same direction. Okay. Any questions about positive relationships? Any questions online? All right, good deal. So let's go back to our slide. Now, conversely, we've mentioned this before, but let's talk about it very briefly. And that is a negative correlation, right? A negative correlation. What that is telling me is that the two factors are going to move in opposite directions. They're going to move in different directions. So before, both factors, if one went up, the second one went up. one went down, the second one went down. However, in the case of a negative correlation, you'll see that if one factor goes up, the second factor will go down. Good example, for instance, was that of your grades. So for example, you get, these will be your grades, right? And this, for example, can be the amount of times you're absent during the semester. So if you're absent 5 times, for instance, your grade is going to be very low, right? If you're absent 4 times, notice how your grade is also going to become lower. Now, something interesting that I would like to mention, if we go back to our previous slide and this slide, because they both illustrate the same thing. I talked about a perfect relationship, right? So we want to be really, really close to that, either positive one, or we want to be really, really close. If I erase this here, we want to be either very close, or our value, we want it to be very close to -1 or +1. This regression line here, notice how all my little data sets, so for example, Joseph's, Joanna's, Peter's, Kendrick, notice that all those points fell perfectly on that regression line. That tells me that this was a perfect correlation, right? It was a positive one. Conversely, if we go to our negative side, notice that this was also perfect because the data sets fell perfectly on that regression line. But notice that if we have anything less than perfect, which is generally the case, especially in social sciences, you'll see how this relationship is not 0, right? Because we do have a regression line. 0 will look like this, right? Instead of being a upward or downward looking line, it would be basically a complete horizontal. So it's definitely not 0. There is a relationship, but notice that it's not perfect. How do I know it's not perfect? Well, because the data sets are generally behaving, right? Generally behaving towards that regression line, but they're not on the regression line, right? So that's why scatter plots are so useful. What the regression line is trying to do, we're trying to minimize the distance between the data set and that regression line. Notice that here, there's no distance, right? They're falling on top of each other. Whereas here with the regression line, what I'm trying to do is minimize the distance, right? Increase that predictability. And the same goes for a negative relationship. Notice that here, the relationship was perfect, right? It was a negative relationship. It's a great relationship, -1. So we have a very perfect relationship. A very perfect relationship because it's falling right on top of that regression line. Whereas here, notice it's also not 0, right? Because it's not a horizontal line. That's perfect, right? That's great. But notice that my points are behaving generally close to that regression line. They're not on top of my regression line. They're pretty close. So any questions about the behavior of those data sets, how to read a scatter plot, whether it be a positive relationship or a negative relationship? All right, good deal. All right, fantastic. Now, when we are thinking about the strength, if we go back to that R, right? Go back to that R value, generally, we are referring to Pearson's correlation, correlational coefficient, right? So generally, that's what I am referring to, Pearson's. There we go. What I'm trying to find out is how consistent, right? The consistency of how each value changes, right? So if we go back to our previous slide, notice that this R that is perfect is a -1, is very consistent, right? So I'm trying to find out how consistent are these plots. If factor X behaves in a certain way, factor Y is going to behave in a certain way, right? In this case, in this case, because it's negative, when one factor went up, the other factor went down. And the same here. With my relationship, with my strength, I'm trying to find out the consistency. I want to be able to predict, right? So if I know the value of R, I can do a general prediction as to if I had X score, Y score is going to behave a certain way. Notice that that's what I'm trying to do, is increase that predictability. I want to find that consistency of those results, right, for each factor. As I noted, the closer the R value is to positive or negative 1, the stronger that relationship will be. Now, conversely, the closer we are to 0, the weaker that relationship would be. Any questions about that strength as it relates to negative or positive or no relationship, right? For example, a 0. My people online? Good deal. So what I'm going to try to do is I'm going to increase this image because it's actually a little small. I'll make it a little bit bigger. Right. Let's make this a little larger. All right, good deal. So if we go back to our slide, what we're trying to do is describe that consistency. So notice that in this case, right, in my first image here, right, we have exercise, right? So for example, how many hours a week? And here we have body image satisfaction. Notice that in this particular set, right, so towards your left of your screen, notice that it's less consistent because the data sets, the data points, the observations are pretty far from that regression line, aren't they? Pretty far. If you see this distance here, all right, they're falling pretty far away from that point, right? So we notice that they're kind of far away from that regression, meaning that they're going to be more difficult to predict, right? Whereas if you look at the right of your screen, we have more consistent data. So in this case, you notice that the distance is actually very small. They're almost on top of each other, right? They're almost on top. Some of them are, in fact, on top of the regression line. So notice that the distance here with more consistent data has been minimized, right? We don't have aspects that are far away from my line. Any questions so far about my reading of less consistent data versus more consistent data? All right, good deal. The same goes for, if we go back to our slides, the same goes for a negative relationship. I would even argue this is almost not a good relationship. But notice that here in a negative relationship, amount of times you didn't show up to class and the grades that you had on the quiz, notice that here this data is less consistent. How do I know that? Because the distance between my data points, my data sets, right, they're falling pretty far away from my regression line. Whereas to the right of your screen, you'll see how these data points, these observations are pretty much on top of that regression line. So it applies for both cases, whether it's a positive relationship or a negative relationship. Any questions so far? Good deal. If I go back to the slide. All right. If we go back to our slides, the correlational coefficients I stated, we were talking about Pearson's correlational coefficient. It's one of the more common statistics that you and I will see in social science, right? We're trying to look and understand the measurement, right? It's a statistic that is going to give me the direction and strength of a linear relationship, right? Now, there's other methods, right? There's other instances in which we make use of other correlational coefficients. So notice, if you look at the bottom of your screen, you'll see, for example, that we have Pearson's, right? So we are referring to interval or ratio data. Sometimes we will have to conduct a Spearman correlational coefficient. That is simply when we are looking into ranked or ordinal data, right? So we can't always use Pearson, right? We can also use Spearman whenever we're looking at ordinal data. We can also make use of point visual. And in this case, we have dichotomous nominal data. What do I mean by that? Sometimes you will have data that is nominal. And if you recall from previous lectures, when we have nominal data, we are talking about basically categories, right? Does it fit in a box, right? Yes and no are boxes, right? So for example, I can give a value of yes, I can give it a 1, and then no, I can give it a 2. Notice that that number doesn't really tell me much, does it? It really doesn't tell me anything other than yes is the category, 1 is the category of yes, and 2 is the category of no, right? It doesn't tell me that 1's better than 2. It doesn't tell me that no is better than yes. It doesn't tell me which one is greater. It simply tells me yes corresponds to 1 and no corresponds to 2. In that regard, when we're using that type of data, it's more important to use this specific correlational coefficient. Now, we can also make use of a correlational statistical sign. In this case, we have that both factors are dichotomous. So any questions so far? Good deal. Good deal. All right, so let's go back to our slides. This is when things start getting a little bit more interesting, right? Because as you know, we are trying to see, right, the variance, right, the amount of change, the amount of impact, right? We're trying to find out the impact or that change in regards to those variables. Now, notice that we have the variance of x, right? How much is x varying or changing, right? And we have the variance of y. That is simply how much y is changing. The issue is that sometimes we will come across a covariance, right? That is how much, to what extent do these factors vary together? And that can happen. That could happen. So say, for example, if you have one variable and there is some, that's why it's called a variable, right? So there's a variability with one factor, and then later on, you're examining the variability of another factor. Notice that that variability can have another impact together, right? So for instance, you may be thinking about a medication and symptoms, right, of a specific illness, but there may be specifically a covariance of that interaction specifically, right? So not necessarily with the variability of X and the variability of Y, there's going to be a variability of them together, right? That's what we call a covariance. There's different types of impacts when it comes to variables, and I think we will cover that a little bit more in detail whenever we start talking about experiments and experimental aspects of statistics. But do notice that if we go back to our slides, the closer, right, those data sets, those data points, the closer these points fall on top of this regression line, right? The closer they fall to that regression line, we can assume that there is more covariance, right? We can say there is, in fact, a variance that is occurring with both factors at the same time. So again, the more the data falls on top of that regression line, the more we can assume that there is a covariance between these two factors. Any questions about that? Any questions about covariance? Good deal. And my beautiful people online, any questions so far? So let's talk about some of the limitations when it comes to interpreting all of this data, right? So we talked about what correlations are, how do we measure the strength of a correlation, how exactly do we know the direction of a correlation. We also talked about, for instance, how do I view my correlation, right? So for example, through the illustration of a scatter plot, we also talked about how to interpret a scatter plot. And this is where it gets tricky, because in some situations, when people are looking into that relationship, they may start talking about cause, right? They may start talking about cause. And when we are looking at cause, notice that people tend to make this mistake. Notice that here, if we go way back in our slides, if we go back to our slides, and I erase this over here, you'll notice that in this regard, whenever we have a strong relationship, it's really easy for people to say, okay, well, there must be a cause somehow, right? There must be an impact, a direct impact upon this relationship. But that is a mistake. Why is that a mistake? That is a fault with your interpretation. Just because something is related does not mean that one caused the other. It does not mean the one caused the other. Think about a very clear example. You are related to your siblings. You are related to your cousins. Does that mean you cause your cousins into existence? Does that mean you cause your siblings into existence? Absolutely not. What that tells me is correlation does not imply causation. And that is one of the main issues that we sometimes come across when it comes to the interpretation of data, right? When it comes to the interpretation of data. Now, if we go back to the slides, I also want to mention that generally, sometimes when people are thinking about that relationship, we would think that things that cause each other, right, will be related, right? That's generally a sound assumption, but not the other way around, right? Not the other way around. And why is that? Well, that is because we may have a confounding variable. Confounding variable. What is a confounding variable? A confounding variable, it's simply a variable that we were unable to anticipate. We were unable to predict. Generally a variable that we did not foresee as a researcher. Not only is it unexpected, right? Not only is it unexpected, but it also has an impact upon your research. It will have an impact upon that statistic. Not only was it unexpected, now it's ruining your data, right? Because here you were, right, looking into what's the relationship between, say, amount of therapy, right? Amount of therapy and the improvement of self-worth. So We have these two variables, but then right in the middle, we're going to have a confounding variable that you simply were unable to predict. Not only is it here in the middle, and it's unexpected, it's also impacting the potential relationship or even the cause of that improvement that you saw with your clients or your patients. That's just simply one example. So any questions about confounding variables? My people here in person or my friends here online? Now, if we move forward towards other limitations, right? Notice that when you're interpreting that scatter plot, you may also be limited in that interpretation because you might have an issue with outliers, right? Outliers. And what do I mean by outliers, right? Outliers is basically a score, any score, that is falling pretty much above or very, very much below the scores in a data set, right? So what do I mean? When we're thinking about a bell of normal distribution, you'll notice that generally towards the center, right? We have our mean, we have our average, and generally your data points are going to fall within or around that general vicinity of your mean. But notice that every now and then, you're going to have a data point that is distancing itself pretty far away. So this is my average. It's going to distance itself either towards the negative or the positive side. That is what we call an outlier. So for instance, we can say the average American household or the average income per person, let's say, is $70,000 in America, right, in the United States. But it might not be because we have outliers, don't we? We have people that live in extreme poverty and we have people who are billionaires, right? So those two data sets, whether living in extreme poverty towards the negative or towards the higher income, right, being a billionaire, notice that those points are going to impact your data. Now, there's measures and ways that we can reduce the impact of outliers. But in regards to our interpretation, notice that that outlier can impact your interpretation, right? Now, another issue that we may come across, right? Another issue that we may come across is the restriction of range. Restriction of range. What do I mean by that? What do I mean about restriction of range? Notice that the data, right, the range of data that you collected is inherently limited to that specific set when compared to the rest of the data of the population. And what does that mean in the Queen's English, right? What does that mean in plain, good old English? It means that that correlation that you saw may only apply to those individuals, to that data set. It may not reflect the range, the scores of the population, simply because you are restricted to the one sample, right? And you've seen that before, right? For instance, you consider yourself to be a smart person, you know, you got some oil in your lamp, right? The light bulb, you know, lights up every now and then. But then in one test, you failed miserably. You'll notice that that was just one sample, right? It was just one range of the entire data set that you have when it comes to taking a test. All right, so that can occur. There's a restriction of range. Now, as I noted previously, we talked about linear regression. What do I mean by a linear regression? What I mean is that we have this regression line specifically pertaining to a certain extent, right? So specific data points. And we're trying to determine whether we can predict the values of one factor, because you already know the value of the second factor. Right? What does that mean? It means that I'm trying to predict, if I have one variable, I'm trying to predict the second variable, right? So that's what we call regression. If X increases, I can predict that Y is going to increase. Right? Vice versa. If X decreases, maybe Y decreases. So that is the point of a linear regression, is to provide that prediction. Generally, our value of X, is what we refer to the predictor variable. Generally, this is what we refer to our independent variable. So not necessarily for this specific instance, but we also refer to the predictor variable as independent. And notice that we also have a criterion variable. Generally, we refer to that in some instances as our dependent variable. So my IV is that known variable. My IV is that known variable. And my Y is the variable that I'm trying to predict or estimate based on what I do know, based on what I do know. So if I know when X happens, right, if X goes down, right, so that's my predictor. I'm trying to use my criterion and say, if X goes down, that means that Y would go up, right? So notice that I'm trying to give you a prediction. I don't know that. But if I know the regression, I can make a good estimate and say, okay, if this one happens, the second one will occur in terms of prediction, mind you, not cause, right? Because I know this sounds pretty close to a cause, but that's not what we're doing with a correlation. So if we go back to our slides, one of the last things that I'd like to mention is, if we do, in fact, know the equation of that regression line, right? So if you remember, I was noting that in a relationship, we have a line, and then depending on, right, where the points fall, we can determine strength and direction. But now I actually want to plot this line, right? It doesn't have to be guesswork. I can actually run a statistic, right? I have my equation in order to draw this line, right? In order to conduct that prediction. Now, in this regard, let's break it down a little bit. Y is going to be my criterion variable, right? So my DV. X is going to be that predictor variable. Now, B refers to the slope. So for instance, that slope could be in this fashion. Maybe the slope is still positive, but maybe it's has a little bit of an incline, right? Or maybe it's super sharp, right? Notice that these are still positive relationships, but notice that the slope changed, right? So that's what the variable B is going to tell me. It's going to give me the slope of that straight line. And A is going to be that intercept. So for instance, if I have my little, oh, that was almost perfect. Look at that. If I have one factor here, right, and I have my other factor here, this intercept, right, the intercept, that is what we are referring to as the y-intercept, right? Think about it as a coordinate in a map, if you will. Think about it as a coordinate, say for instance, in Battleship. Right? It's a really good way to remember what y-intercept is. The good thing is, if I am using a linear regression and I'm using this equation, I can predict. I can't predict how certain people may behave or may perform. But the concern, however, is that small correlations, right? So for example, I have a relationship where maybe it's a 0.3 and it's a pretty low relationship. So it still behaves in that general area, right? But notice that the points are pretty far away from my line. For example, I have an R of 0.3, right? It's a pretty mild relationship at best. So the closer we are to 0, we may have inaccurate predictions. So if you notice, if you remember from our previous slides, we actually had a good example like that. So notice this data is less consistent, right? So maybe this is a really weak relationship. So for instance, a really low value, right, of like 0.3 or 0.2, barely related to one another. So notice that it doesn't fall on my line, on my regression line. Therefore, if I say if 2, therefore 4, if 4, therefore 6, notice that I wouldn't be able to make such a straightforward prediction. So you see how the predictions are less consistent, right? Whereas here, it's pretty straightforward. Whereas here, the data is pretty poorly related. So you notice it's not following in a good line, like in this case, right? With more consistent, stronger data. So any questions about that? All right, so that brings us to the end of our lecture. Thank you very much for your attention.